there are 4 tables that you're supposed to memorize. The first one will be cation tables, anion table, gases table, and solubility table. So just take note for students, these 4 tables you are supposed to memorize for the exam, okay, because the table are not given to you. Alright, let's go through the first table. So first table, this is just the first half of the table because I can't squeeze in everything. So basically, in order to test for cations, right, you have to use either what? Sodium hydroxide or aqueous ammonia. So let's look at sodium hydroxide first. For zinc, aluminium, lead, and calcium ion. So first, you will add a few drops of sodium hydroxide. So you will get your white PPT for zinc hydroxide. Aluminium ions, you also get white PPT. Lead ions, we also get white PPT. So as calcium ion, you will get white PPT. So just take note, all these white PPT, right, are all metal hydroxide. Basically, this one will be like zinc hydroxide. If it's aluminium, it will be aluminium hydroxide. If it's lead, it will be lead hydroxide, so on and so forth. Okay, and then in the second stage, okay, after you add a few drops, right, then you add in excess. So you see whether the PPT actually dissolve in excess. Okay, so for zinc, aluminium, and lead, right, these 3 ions, right, will actually dissolve in excess to give you a colorless solution. So just take note for this. So if it's soluble, you have to say it give off what color solution in the end. Okay, so whether it's PPT, what PPT, and then can it dissolve? If it's dissolved, what color of the solution? Okay, so basically there are 3 points. Okay, but for calcium ion, if it's insoluble, then you just say it's insoluble in excess. That's all. Okay, and then you can also use aqueous ammonia to determine what cations you have in the solution. So for zinc, aluminum, and lead, it's all the same. It's all white PPT. But for calcium ion, right, there's no PPT at all. And then if you add in excess aqueous ammonia, only zinc ion actually dissolve in excess to give you a colorless solution. Whereas for aluminum and lead, both are insoluble in excess. Okay, so take note the slightly difference between sodium hydroxide and aqueous ammonia. Okay, so all these you have to memorize in your head basically. So that's why it's a star there. Okay, so whatever is there's a star means you have to memorize by heart for your exam. Okay, it's not given. Next one. Okay, so before I move on, this one try to take note because some students will ask, right, how do you get hydroxide when you're adding aqueous ammonia? Because aqueous means what? Water, and then ammonia is NH3. NH3 will react with H2O, right? Give you NH4 plus and OH minus. This is where you get OH minus. So meaning even though you're adding aqueous ammonia, right, the OH minus will react with the cation to give you all your PPT like zinc hydroxide or aluminum hydroxide. The hydroxide, the OH, right, actually come from here. Alright, okay. Next one, so this is the part 2. Okay, so there are the other 4 cations, which is copper, iron 2, iron 3, and ammonium ion. Okay, so if you add sodium hydroxide, right, you will get a light blue PPT, and then it's insoluble in excess. Okay, and then iron 2 will be green PPT, insoluble in excess, and then iron 3 will be reddish brown PPT, insoluble in excess. Okay, but for ammonia is very unique. There's no PPT produced. But on heating, right, ammonia gas will be given off, and then how do you test for ammonia gas? It will turn what? Moist red litmus paper blue. Okay, so slightly different, slightly unique, so just watch out for this. Okay, so these are all the unique color like copper hydroxide, FeOH2 or FeOH3. Okay, if you add aqueous ammonia, will be very similar, okay, as this one, except for this part here. Okay, for copper ions, ions, right, blue, light blue PPT, okay, CuOH2 in excess aqueous ammonia actually dissolve to give you a deep blue solution. It's not a colorless solution, it gives you a deep blue solution. So slightly unique, so watch out for this one as well. Okay, so make sure you memorize this whole table. Usually the tips to memorize this is what? Try to memorize anything that is unique. Whether it's white PPT, right? Usually we don't memorize it. We just memorize whatever is a unique color. Okay, something more outstanding, then we memorize it. Okay, we will be doing anion tables. So for your syllabus, basically there are 5 anions: CO3 2 minus, NO3 minus, SO4 2 minus, Cl minus, and I minus. So let's look at the first one. For carbonate ions, how do you test for carbonate ions in your unknown solution? So you need to add dilute HCl acid, okay, and then pass through the gas into lime water. So basically it can be any acid. So usually we just use HCl acid, okay. You can use nitric acid, HNO3 as well. It doesn't really matter. Okay, so observation will be effervescence is observed, and then white precipitate is formed. CO2 gas is produced. So in case you are interested, what is this white precipitate, right? It's actually calcium carbonate. Okay, your limestone, calcium carbonate. Okay, because sometimes the question they might ask you, what's the white precipitate is from? Okay, it's calcium carbonate. So, and one more thing to take note, whenever they ask for how do you test for CO32 minus, right, you don't just give the test. What the question wants is basically the test and the result. So everything, okay, the test and observation. Next one, how you test for nitrate ions. So you have to add three things in, okay, aqueous NaOH, and then aluminum foil, and then you need to warm the solution. So these are the three keywords. Okay, observation, effervescence is observed, and then the moist red litmus paper will turn blue. So how do you test for ammonia gas, NH3? Next, how do you test for sulfate ions? So you add dilute nitric acid, and then you add what? Aqueous barium nitrate. Okay, then in the end, you'll get what precipitate of barium sulfate is formed. Okay, so just take note, for the last three, right, you realize, right, you always add what? Nitric acid. Okay, for testing of sulfate ions, Cl minus and I minus, right, adding of dilute nitric acid is to what? Remove any possible carbonate ions that might be present in the solution. Because if you do not add any acid and you just add aqueous barium nitrate, you get a white PPT, right? This white PPT might be barium carbonate. Okay, it can't tell you for sure that it must be barium sulfate. It might be barium carbonate. So how do we eliminate the possibility of carbonate? So you have to add nitric acid. So once the nitric acid will react with your carbonate to form CO2, okay, it will be no longer in the solution. Then if you add aqueous barium nitrate and you really still get a white precipitate, right, means this white PPT must be barium sulfate. Okay, next, same thing for chloride. Okay, you add nitric acid to get rid of any possible carbonates inside. Maybe yes, maybe no. Okay, and then you add aqueous silver nitrate. Okay, then you get a white precipitate of AgCl. Silver is from here, and then chloride is from your unknown solution. Okay, then next, iodide. Okay, same thing, nitric acid, get rid of any carbonates ions. Then you add AgNO3. Then you get a very nice yellow precipitate of AgI. Okay, so the next few slides, I will show you the color of all this yellow precipitate, how it actually looks like, okay, and your AgCl and BaSO4. Okay, so this one, just take note, for higher order thinking question, right, they might actually ask this type of questions. Okay, why is nitric acid added, or why dilute nitric acid is added when you're testing for this 3 anion? Okay, and then this one, just let me repeat again. So what is this white precipitate form? It's actually calcium carbonate, CaCO3. Okay, so just remember this. Doing gases table. So in your syllabus, basically there are 6 gases. So let's look at the first one, hydrogen gas. So how do you test for hydrogen gas? You'll use a lighted splint. Okay, so observation, there are 3 keywords. Okay, the lighted splint will extinguish, and then with a pop sound. Extinguish with a pop sound together with lighted splint. These are the 3 keywords. Okay, the pop sound, take note. Next one, oxygen gas. So you'll use a glowing splint. So for hydrogen gas, it's a lighted splint, but for oxygen gas, it's a glowing splint. So take note of the difference. And then the observation, it will rekindle or relight. Okay. Next one, CO2 gas. So you just bubble the gas through lime water, which is similar to the previous slide. And then you have a white precipitate of calcium carbonate is formed. Okay, that's all. This one is actually optional. You don't have to write this. You can just write white precipitate of calcium carbonate is formed. Okay, but in for general knowledge, okay, if you dissolve even more CO2, right, okay, the PPT dissolve upon further bubbling. So basically, the calcium carbonate will react with CO2 to form something that is soluble, aqueous. Okay, next one, Cl2 gas. So you will place a piece of moist blue litmus paper, okay, at the mouth of the test tube. So there will be 2 changes. First, the moist blue litmus paper will turn red, then it will bleach. Okay, it will turn red first, then it will bleach. Okay, so in case you want to know why, the reason is this one. Okay, your Cl2 react with your H2O, the water on the litmus paper, that's why it must be moist, to form what? HCl plus HClO, hydrogen chloride. Okay, so HCl is actually lighter as it has a lower molecular mass than HClO. Thus, the litmus paper, right, will turn red first because of HCl, which is acid, then it will bleach because of this one. Okay, it's a bleaching agent. Okay, next one, SO2. Okay, SO2 once in a while it might come out, not as common as the other 5 gases. So you'll use a acidified potassium manganate 7, okay, at the mouth of the test tube. So you'll turn from purple to colorless. Okay, still remember this one, potassium manganate 7 acidified is actually your oxidizing agent. So if your oxidizing agent is being reduced, it will turn from purple to colorless. Okay, because SO2 is a reducing agent, so it will reduce potassium manganate 7 from purple to colorless. And then of course the last gas, ammonia gas, NH3. So you will use a moist red litmus paper, it will just turn blue. So this one should be an easy one. Okay, chlorine gas. So you use a moist blue litmus paper, place it at the mouth of a test tube. So the moist blue litmus paper will actually turn red first, then it will bleach. Okay, so for those of you who are interested why it will turn red first then bleach, this is the reaction going on. Cl2 react with H2O. Okay, the water comes from the moist litmus paper. Okay, the moist. Okay, you will form HCl plus HClO, which is your hydrochlorous acid. Okay, so first, HCl has a lower relative molecular mass than HClO, thus it will diffuse faster. Okay, so meaning HCl will come out first. Okay, hence the litmus paper will turn red first because it's acid, and then it will bleach because this is a bleaching agent. Okay, next one, your SO2. Okay, so this usually will not come out, but just for competition's sake. Okay, you'll use a piece of litmus paper soaked with acidified potassium manganate 7. Okay, because SO2 is your reducing agent, and then acidified potassium manganate 7 is your oxidizing agent. So if you react both of them together, your oxidizing agent will actually turn from purple to colorless. Okay, and then of course your ammonia, your familiar gas, ammonia gas, you use a moist red litmus paper, it will just turn blue. Okay, next one, the last table that you need to memorize is your solubility table. So this tells you the solubility of the salts. Okay, so for the first row, all sodium, potassium, and ammonium salts are all soluble. Okay, it doesn't matter it's sodium hydroxide, sodium nitrate, sodium sulfate, or whatever, it will all be soluble. Okay, nitrates as well, all nitrates are soluble, meaning it can be copper nitrate, iron nitrate, silver nitrate. Okay, all of them will be soluble. Next one, chloride. Okay, all chlorides are soluble except for these two, lead chloride and silver chloride. So usually when we memorize, we just memorize the more unique one. Okay, like these two, all chlorides are soluble except for which one? Lead chloride and silver chloride. Okay, lead 2 chloride and silver chloride. Sulfate as well, all sulfates are soluble except for these three, calcium sulfate, barium sulfate, and lead sulfate. So these are the three sulfate that are more unique and you need to memorize them. Next one, carbonates. Okay, all these three carbonates and other group 1 carbonates are soluble. Okay, whereas the rest are all insoluble. So usually I'll just memorize this one, and this one. Okay, so these are the more unique one. Okay, insoluble. Whatever you did not memorize, most likely they will be soluble. Okay, so these two, we'll just watch out. Chloride salts and sulfate salts, very common, they will come out. Okay, and most carbonates are insoluble except for these three, sodium, potassium, ammonium, and other group 1 carbonate. Alright, lastly, how you test for your water. Okay, once in a while it might come out. Okay, so you have two tests. You have two tests to test for water. So either you can add what? Place a piece of cobalt chloride 2 paper at the mouth of a test tube when you heat a sample. Okay, if your filter paper changes from blue to pink, okay, blue to pink, it means water is present. Because if it's anhydrous means dry. Okay, it will be pink in color, but when it's hydrated, when the water goes in, okay, it will become blue in color. Okay, and then, but this one is the more common one. You add a few drops of what? Anhydrous copper 2 sulfate. Okay, it will turn from white to blue. When it's anhydrous form, it's white in color, but when the waters go in, it will become blue in color. Okay, so this is this hydrated copper 2 sulfate, which I think most students will be very familiar with. Okay, you'll be doing this experiment. Okay, so just remember the color. Next one, so this shows you some of the common colors of copper compound. So remember, for you, when you're testing for cations, especially for copper, right, you get a light blue PPT. So this is how it looks like. Okay, so like blue, some blue solid. Okay, don't worry, you'll be doing this experiment. Okay, and then still remember, it is in aqueous excess ammonia. Okay, your blue PPT, right, in excess, it will dissolve to give you a deep blue solution. So the blue PPT actually dissolve to give you a blue clear solution. Okay, dark blue solution. And then it's good that you need to memorize other carbonates compound, what are their color. Copper 2 carbonate will be green in color. So this will be very useful when you are doing your QA flowchart questions. Okay, so they say there's this unknown substance which is green in color. So copper 2 carbonate might be a possibility, and actually it come up quite often. So it's good that you know. Okay, it's green in color, solid, and then copper oxide, copper 2 oxide (CuO) is actually black in color. Okay, so just remember this one. Next one, okay, your iron compound. So this one in the cation table already memorized. Iron 2 hydroxide, okay, FeOH bracket 2 is actually green in color, okay, green PPT. And then your iron 3 is actually reddish brown PPT. So you'll be doing experiment, and most likely this is what you're going to see, okay. And then, but take note, students always get confused for iron 2 and iron 3, whether it's a solid or solution. When it's a solid form, right, okay, is green in color, and it's iron 3 solid is reddish brown for the ion, okay, I mean for the PPT. But in the solution form, right, it's actually pale green, okay. But for iron 3 solution, it's actually pale yellow. So take note, reddish brown is for iron 3 hydroxide, but for iron 3 solution, it's actually pale yellow. So watch out for this one. So you must always take note in a question whether it's in a solid state or in a solution state. So the color will differ. Okay. Next one. Okay, your silver iodide. This for testing for iodide ions. Still remember your yellow PPT of AgI. Okay, so this is the yellow color PPT. And then how you test for sulfate ions and chloride ions. You will form your barium sulfate, which is white PPT, or you'll form silver chloride, which is white PPT. So actually, as long as you form white precipitate, right, it will look something like that. Okay, so you can't really tell the difference. Basically, it's just white in color. And then of course, how you bubble your CO2 gas into lime water, you'll see your white precipitate. Okay, so still remember what is this white precipitate? This precipitate is a calcium carbonate. Okay, calcium carbonate. So take note of this. Next, and then of course, iodide. Okay, in aqueous form, solution is actually brown in color, but in a solid form, it actually purplish black. So there's a slight difference whether it's a solid state or it's an aqueous state. And of course, sulfur. Okay, sometimes you might have this solid which is yellow in color. So sulfur might be one of the possible substance for it. Okay. Next. Alright, so let's try the first question. So most likely, usually when you are having QA questions, right, qualitative analysis question, it will come in the form of a flowchart. Okay, so how do you deal with it? Okay, so they give you all this solution, then they give you the test, then you get this colorless solution, okay, so on and so forth. So what you need to watch out is what is the reagent that you add in, and what are the colors you form, and whether they are soluble or whether they are precipitate. Okay, so let's try this one together. Okay, I don't know whether you can see this, so if you cannot see, just go back to the previous slide. Okay, so let's try this one first. Okay, so when you add hydrochloric acid, so what does HCl has? It has Cl minus. Okay, you have Cl minus, and then take note, this solution A has what? Ag plus, Cu2 plus, Zn2 plus, and Fe3 plus. So which of these 4 cations, right, will react with Cl minus to give you what? A precipitate. So the first thing that comes to your mind, which table should you refer to? You should refer to your solubility table. Okay, solubility table. This one. So under chlorides, okay, all are soluble except for these two, lead or silver. So in this case, you have silver here, okay, so most likely B will be AgCl. Okay, so that is how you determine it. Okay, can't be copper chloride or zinc chloride or iron 3 chloride, they are all soluble. Okay, so that is how you deduce using the table accordingly. Okay, next one. Next, cation. Okay, how can I know I need to use cation table? Because whenever you see they say add excess sodium hydroxide. Okay, so when adding excess sodium hydroxide, right, is the clue to tell you that you are testing for the cation. You're trying to figure out what is the identity of the cation. So I just put the cation table here for easy reference. So let's look at this one. Okay, you add excess sodium hydroxide. Okay, you get a colorless solution. You get a precipitate C and D. Okay, so you only left what? Copper ions, zinc, and iron 3 plus. Okay, which of these, right, will give you a colorless solution in excess? Okay, is it zinc? Is it copper 2 plus or iron 3 plus? So you just look under this column here. So if it's iron 3 plus, you got a PPT. So most likely iron 3 will be somewhere here. And then you get a copper 2 plus, is also PPT insoluble in excess. So most likely it's here also copper. Okay, so only left zinc. Zinc is ZnOH2 and then dissolve in excess to give you a colorless solution. So I know this must be my zinc ions. Okay, that's how you do it. Next. So this will be my copper hydroxide and my iron 3 hydroxide. Okay, FeOH2 and CuOH2. Okay, then furthermore, now they come down. When you add excess equals ammonia. So now we are doing, we'll be looking at this column here. Okay, where it's excess equals ammonia. So in excess, one of them will give you a solution, one of them will give you a precipitate. So let's look at copper. Okay, copper hydroxide in excess, it will give you a deep blue solution. Whereas iron 3, right, will give you a reddish brown PPT. So most likely, this one will be my copper ions because it gives you a deep blue solution, okay, a solution. Whereas this one must be my copper hydroxide. Okay, so basically that is how you solve it. So usually when we get a flowchart, we will figure out the identity for everyone first, then we will transfer the answer into the question. So let's try this one. Okay, so now once we have the identity for everyone in the flowchart, we can look at the question. Name the following substance, precipitate B. PPT B will be AgCl, okay, silver chloride. Okay, what about C? Okay, and D. Okay, C and D, it can be either one of them, it doesn't really matter. Okay, so it will be iron 2 hydroxide and then copper 2 hydroxide. Okay, then what's the color of precipitate E? So iron 2, still remember just on the picture, or you can refer to your cation table, it should be green PPT, green color. And of course, your solution F, okay, it dissolve, blue PPT, dissolve in excess to give you a deep blue solution. Okay, so that's why you need to memorize the table. For now, you can just refer to it, but in the exam time, you have to memorize it. If not, you can't really solve anything. Okay? And then next, you need to write, sometimes the question will ask you to write ionic equation, right, to produce B, C, and D, which is your PPT. B is this one, silver chloride. So there's a shortcut to write ionic equation. Okay, I'll show you here. So for PPT B, right, you need to form what? AgCl. Okay, so you can write down something plus something give you AgCl solid. So take note, ionic equation, you need to write the state symbol. Okay, so just think logically, what cation and what anion give you AgCl? So obviously it's your Ag plus Cl minus, that equals. That's all. Okay, so that is an easy way to write your ionic equation. You write out what is the endpoint you want to form first, then you go back to figure out what are the reactants, okay, what ions to form. Okay, you try again. For C will be your FeOH2 solid PPT. Okay, so what cation, what anion? So your cation obviously will be iron 2 plus, if you reverse cross, equals, and then your hydroxide, which is OH minus, equals. Okay, so you realize that I put a 2 here because it must still be balanced at all times. How many hydroxide it has? It has 2 here. So the other side, the left hand side, you must also balance it, put a 2 here. Okay, so here is just one Ag plus and one Cl minus, so it's 1 1 here. Okay, then lastly, how you form D? D will be your copper hydroxide. So same thing, copper ions plus how many hydroxide? 2 of it again. Okay, so it's 2 OH minus. That is how you solve it. Okay, so usually they ask for the identity, the color, and write the equation. It can be chemical equation or it can be ionic equation in this case. Okay, next one. So these are the answer, just in a bigger font. Practice question 2. So let's look at this one first. So first we'll start from the top here. So let's look for the reagent that you add in. Warm with aqueous sodium hydroxide and aluminum foil. So you should always look for the very unique test. So this test remind you of which one? Okay, aluminum foil. So most likely is a anion. Okay, anion table. So which anion you actually add what? Sodium hydroxide and aluminum foil in the test. So it's actually this part here. Add equals sodium hydroxide, aluminum foil, and then you warm it. Okay, so effervescence, a gas E that turn red litmus paper blue. So NH3 here. Okay, so here gas E must be NH3, and this shows that what? Nitrate ions must be present in here. Okay, in the yellow solution. So you can put NO3 minus first. So if you only know the N ions, right, you can just put NO3 minus. Then we'll figure out the cation ions later. Okay. Next, let's look at this one. Aqueous sodium hydroxide. So same thing again. This one, just now we mentioned before. When you add aqueous sodium hydroxide, is to test for cation ion. So let's come out with the cation ion table. Green PPT. So which one? Sodium hydroxide. So this column here. So green PPT is this one. Okay, iron 2. So it will be iron 2 hydroxide. Okay, and then so where does the iron 2 plus come from? It doesn't come from here. Okay, so green and then yellow. So iron 2 plus is from here, and then it undergo reduction to get iron 2 plus. So if you go backwards, it will be oxidized. Iron 2 will be oxidized to iron what? Iron 3. So remember just now we mentioned iron 3 is actually yellow solution. Okay, and then next, acidified potassium manganate 7. Still remember, is a what? Oxidizing agent. Okay, and then you have a black solid here or reddish brown solution. So oxidizing agent. So this one most likely is our I2 solid. And then this reddish brown solution, right, is actually I2 aqueous. So the slide that we show you just now, again, is actually brown in color. So just take note, work backwards. If B, you oxidize it to become I2. So if you go backwards, right, you'll be reduced. I2 reduced to become what? I minus. Okay, still following? Colorless solution. So I minus is colorless solution. So this I minus come from where? Go all the way here, okay? And then to here, I minus. Okay? Next. Okay, so these are the questions. So same thing, we always fill up everything in the flowchart first, then we transfer all our answer here. Okay, so identify the ions in A, B, and C. So in A, because it's yellow color, so yellow color is due to what? Iron 3 plus. Okay, and then B will be your here, I minus, and then C will be iron 2 plus. Okay, two anions in salt A and B. So same thing again, NO3 minus and I minus. And of course, who is D? Where is D? D is iron 2 hydroxide. Okay, so these are the answers. Next, question 3. So this one. So this one I'm not going to come up with the table, so you can just refer on your own, or you can just try with your memorizing. So you can start from this one, copper nitrate. When you heat it strongly, means it will just decompose. It won't react with anyone. To give you copper oxide, brown gas A, and the colorless gas B, which will relight a glowing spleen. Relight glowing spleen means what? Still remember, must be what gas? Your oxygen gas. Okay? Then just think backwards. Copper nitrate to give you CuO, O2, and what is this one? So if you think backwards, where is your N going to be? Okay, so must be something with N. Can't be N2. N2 is colorless. So the next logical gas will be what? NO2. Okay, so you have to think backwards. Okay, then next, move on here, downwards. Copper nitrate, when you dissolve in water, become aqueous. Then same thing, let's look at the test. Okay, one with aqueous sodium hydroxide and aluminum foil. So this one, it came out quite a few times. So this is a test for what? Your nitrate ions. Okay, and then you will get what? What will you get? Okay, you get your ammonia gas. Okay, and then of course your copper hydroxide. Okay, because you add sodium hydroxide, you have your copper ions. Of course, you have your light blue PPT, which is your copper hydroxide and ammonia gas. And lastly, the last one, copper nitrate. You add this reagent X to give you green PPT, copper carbonate. Okay, from copper nitrate to copper carbonate. So basically means what? It's an exchange of ions. So you can add anything that has carbonate inside, which is an aqueous solution. So any soluble carbonate like sodium carbonate or potassium carbonate. So in this case, I just use sodium carbonate. You can use potassium carbonate as well. Okay, anything carbonate that is soluble is good to go. Okay, next one. So here are the questions. A, B, C, D, and X. So A will be your NO2, nitrogen dioxide. B will be your oxygen gas. C, where's C? C is here, ammonia gas. And then D will be your copper 2 hydroxide. X will be your sodium carbonate. Okay, so next, write the balance equation for the reaction when copper nitrate is heated. So copper nitrate, when it's heated, right, it will give you these three products. So you just write the equation and balance out. Okay, copper nitrate give you copper oxide plus NO2 plus oxygen. So when you balance it, will be 2, 2, 4, 1. Okay, for those of you who need a video to teach you how to balance the equation, right, just let us know in the comment, and then we will make a video on it. Okay, so for this one, you don't have to write the state symbol unless the question says so. Okay, but for ionic equation, you must write state symbol. Okay, so write the ionic equation to form blue PPT, meaning your copper hydroxide. So very similar. Okay, the shortcut is what? You write copper hydroxide first, solid. Okay, which two ions add up to give you copper hydroxide? Of course, it's your copper ions, and then your OH minus, two of it, so it's 2 OH minus. Okay, that's it. So that's the end. Okay, so remember to let us know in the comment, and don't forget to like, share, and subscribe. Okay, bye.